I'll get to that after we do that. Yeah. Okay, 2.2 is okay. We went through this yesterday, so all it is today is just going through and looking at it. Page 49. So you actually can use, this is the one section, one of the few sections that they're actually going to let you use the graphing calculator for, just to speed things up. So, what I'm going to do, so we're on page 49. We did page 48 yesterday. So what I'm going to do right now is I'm going to graph this for you. So we're looking at, find the domain and range for y equals x squared plus x minus 5. So let's graph that. All right. Domain for that graph?
X in element of all reals.
X in element of all reals. Range for that graph?
Y is greater than or equal to negative 5.
0.25. Look at the graph on there. Okay, so negative 5.25. Now, yesterday we talked about the square root. So I cannot take the square. So when I want to take the square root of the whole thing, the whole graph, that means I'm taking the square root of all the y values, right? Yeah? We get that or no? Okay, so so looking at this, what was the one thing that I said we have to identify yesterday that we had to remember when we're graphing square roots of functions? Can't have a negative square root. There's one. Okay, so what's my starting one at? On my original, what's the first y value I can take a square root of?
0.
0. So that's this guy right here, right? Here. There and there. There's my starting. What's the one invariant values? Meaning what is the one that it actually goes through in both cases? So remember, I'm taking the square root of all the y values of this original. So I'm taking the square root of this. So 0 and 0, right?
Yeah.
Okay, what's the next one that's an invariant value? What value do I take the square root of and end up with the same number?
1.
1. Right there and right there. Right? Square root of 1, 1? Yes or no? Okay. What was the third thing that I had to remember to do? There was a catch on this.
Oh, but they have to be like wider than, it can't be like straight, it has to be wider than the original.
Because why? No. When I take the square root of a fraction, what happens? It gets larger. The square root of a fraction gets larger, right? So then the graph has to go like this. And there's the square root of that graph. Okay? So you have to remember to take a little bit higher than the original line because the fractions, when you take the square root of a fraction, you end up with a larger fraction. Fair enough? Okay? That's all there was to it. Now, let's follow through this and let's fill in our blanks. The graph shows that the function extends to the left and right infinitely. So the domain of the function is x is an element of all reals, right? The function opens upward, has a minimum value of minus 5.25. So the range of this function is y such that y is greater than or equal to minus 5.25, where y is an element of all reals. When considering the domain and range of the square root of x squared plus x minus 5, remember that you cannot take the square root of a negative number. So you can only find the square root of this function, x squared plus x minus 5, when
It's
greater than or equal to 0. To find the values for which y equals x squared plus x minus 5 are positive, determine the values of the zeros of the function or the x-intercepts of the graph. Now, if you remember from grade 11, they used 3 terms to describe x-intercepts. Well, one of them is x-intercepts, roots, right, and zeros. So if you're using a calculator, you look for zeros to get this value here, this value here. They also call them x-intercepts because that's where they cross the x-axis, and they call them the roots. Okay? The x-intercepts are approximately, in this case, 2 and negative 3. Therefore, the domain of this graph. Okay, so this is the next part. How do I then write the domain for this graph right here? Now it's based solely on the original graph. So what part of the original graph did I use? Well, I used from here that way. Agreed? So I go x such that x is less than or equal to
-3.
Yeah, negative 3, it's actually negative 2.79, comma, x is greater than or equal to
Same thing.
1.79, comma, x is an element of all reals. And we must attach squiggly brackets. So there's your domain. Now I write it in this form so that I can identify that it is 2 parts to this. All right? What is the range of this function?
Why can't equal 0? Why can't be less than 0?
Okay, so then how do, okay, you're exactly right. Y can equal 0, but can't be less than 0, so y should be then y.
Y is greater.
Absolutely. Okay? Now I'm going to do this, just change it up. 0 to infinity. Remember, there's 2 ways in which you can write domain and range, correct? Okay? So in this case, square bracket includes, can't include infinity because you never get there. Fair enough? Okay? Any questions about that so far? And working example 3 is just taking the sketch and drawing it out. So that's all I need to do. Thanks. All right. Okay, so that's 2.2. And 2.3 is solving radical equations graphically. We'll leave that until Monday. Okay, Tuesday, right. Questions today?
page 45.
Yeah.
5. Can you just explain how to see it? Like when you're finding your.
Okay, yeah. Let's do this. This is Callan, how can I help you?
Oh, I need a few. Can I see on first?
He's finishing a test.
Oh, okay. Is Jill in this class?
No.
No, she's not. Okay, she's not.
You
So when
need
he's done.
1.
Come find me.
That's a lot less than a few, Mrs. Callan, for the record. Okay, you know what the easiest way to start this is? The AB's are the hard part, right?
Yeah.
So start with H and K.
Okay.
So in 5A, what's my H? What is it?
-4.
It's 4, you go left 4.
I go which way?
Right?
You go right
Or
4, but it would be.
But then it's negative in the
Yeah, so it's a subtracting side, but
Oh.
when I label it,
It's 4.
it's a +4. So it turns to an add in the brackets if I put it down as a negative, right?
Yeah.
Okay, so all right, and K value is what?
+1.
+1. Okay. So now, this is the part that makes it more difficult. If you look at that graph, your 1, value, okay, moves to the right and up. Okay, so let's focus on this guy for right now. All right, my 1, value moves over to the, and I don't know if there's, I'll try it this way and see how we do. So this would be 5 and 2, right? That's kind of where it would be if I had no A and no B. You agree? But it's actually 5 and what? 4. So what have I done to the Y value? Times it by 2. So which of these two affects the Y value? A. So that becomes a 2. Okay? That may not be the best way to do this, Jesse. Because I stretch and I compress first, right? So what I would do is I would look at that value. I look just to the right of it, very right of it, and I see where that value went, and because it should be 1 up and 1 to the right.
Yeah.
But in this case, it's 1 to the right, and I guess it's 3 up. Or actually, it should be, yeah. So it's 2 up from what it was. So that's how I got my A value, which means B is 1, and that's it. Okay? I don't know if that's the easiest way to do it. I'm not sure. But that's how I approach it. So let's look at B together, okay? So in B, what's my H in B?
3 to the left.
So what's my H?
3.
-3, good. What's my K?
-2.
Great, okay. Now, right 1, up 1, and it looks like it's moved more than that, correct? Okay, so what do we think here?
The Y value is 2, or A is 2.
A is 2?
Yeah.
Again?
Because from 1, it goes 1, 2, and from 4, 2, it goes 4, 4, and then from 9, 3, it goes 9, 6.
Okay. All right, I agree with you, Trent. I don't agree with the first one that we did. I think we made an error in the first one. Okay, so let's go back. So this one's right. That's right. Okay, this guy's not right. So how do I figure this out to make it make sense and make it right?
That's what it is in the back of the book. No, it's, yeah, what was the first one? It's 3.
Yeah.
A is
that-
3.
Right, so how do I get to that?
You just have to figure out like your initial coordinates, so like your 1, 1, and like 4, 2 and stuff, and then just figure out your second coordinates and then see the difference. That's what I did.
Right, okay. So in this guy though, we thought it was 2. Because I said, well, 1, 1 went to 5, 2, and now it's 5, 4, right? Assume that that's what happened there, correct? But what we've actually done, because of the order, I can't do it in this order here. Because I can't make those first. So what I need to try and do, my H and K I do right away because it's all based on 0 and 0.
Yeah.
But I have to do the A and B based on that 1, 1 right away. Okay? So the distance between those two is actually 3 instead of 1, correct? So that means it was multiplied by a factor of 3 and then shifted right and up 1. Does that make sense?
Yeah.
Okay. Now, I said this before in the last unit, you may not have to move B. There's certain graphs that you may not have to move B. You might just work with A and that's it, and leave B as is.
You always
Or
have
vice
like
versa.
B, like B is always 1.
Yeah.
It can't be 0.
No, it can't be 0, because then you get 0 times x, which would be 0. So you wouldn't have an actual graph.
Okay.
Okay? All right, so you try the last two on that. Was there other questions from yesterday?
No.
Trent?
6B and C.
Sorry?
6B and C.
Okay. So describe the transformation that were applied to y equals root x to obtain this function. Okay, so what were they?
A equals a half and B equals 1/6.
Okay, yeah, all right, but you gotta be careful there. A is a half, which means you stretch all your y values, you multiply all your y values by half, right? B is still 6,
Yeah.
right? But you're horizontally stretching by a factor of 1/6. But you still write B as 6, okay? So you're dividing all your x values by 6, right? Okay. Write a function equivalent to y equals 1/2 square root 6x in the form y equals a root x. Describe the transformation applied to y equals root x to obtain this new function. All right. So, a little bit of work here with this. Square root 6x, right? I can put them all underneath one square root value, or I can separate them. Okay? I can separate it into this. Okay? And if I do that, and I have the 1/2 here, that's the same as, and will give me the same graph. That's all there is. So if you're only working with the a value, that's what your a value would be, root 6/2.
I got it.
Okay? It's kind of gimmicky almost. All right? Now the next part is a little harder. Okay? Because now I need that to become a square root without changing the value. So to do that, I don't know if you remember this from last year, probably not. If I want to make it a square root, I have to make it a square root and square it. Remember that? Okay, so let me put it like this. If I had 3 square root 2 and I wanted to make that one whole radical, okay, I needed to make this a square root. Well, how can I make that a square root without changing the actual value? Right? Which gives me root 9, root 2, which is root 18. You remember that from last year?
Yeah.
Okay? I'm going to do the same thing right here. So that'll be the square root of 1/2 squared. This. What is 1/2 squared?
A
A quarter. So that gives me 6x over 4. Right?
Oh, okay.
And then reduce the fraction. Okay? Not sure why, but it's working with radicals more than the square roots. Okay? Which is a grade 11 thing. Alright, so you have 2-2. You don't have much time. 12-13 minutes to finish 2-2 today or work on 2-2. There's not many questions in either one of these sections. So we'll do 2-3 on 2-3 on Monday. Alright? No other questions there, grade 12s?
Nope.
Okay.